A medical study has shown that the first 20 days of radiation therapy, a particular type of malignant tumor decreases at a rate according to the function m prime of t equals negative 0.0016 t squared plus 0.02 t, where m represents the mass in grams of the tumor and t is the time in days since the beginning of the radiation treatment. If a tumor of this particular type has a mass of 150 grams just prior to the start of radiation treatment, rounded to the nearest tenth, at what rate will the tumor be changing in 5 days? So let's think about things here before we start jumping into answers. So we have given to us m prime of t, and that was negative 0.016 t squared plus 0.02 t. And we're told that that is m represents the mass in grams of the tumor, and t is time in day. So this tells me the rate of change of the tumor with respect to time. So its unit is grams per day. Now, this concept of something happening per unit time, that is what a derivative does for you. Or at least that's one interpretation of what a derivative does for you. So if you're asking questions like, at what rate are things happening, then that's asking you to evaluate a derivative. So the answer to part A, what we're looking for is because we want the rate at which the tumor is changing, we want to evaluate the derivative after 5 days. We want to see how it's changing after the 5th day. So that would be negative 0.016 times 5 squared plus 0.02 times 5. So we're just plugging into the function given. And we'll use the calculator, of course, to figure that out. So negative 0.016 times 5 squared plus 0.02 times 5. So that's negative 0.3. And that is in terms of grams per day. So it's decreasing in size of negative 0.3 grams per day. Should have made that a bit better of a slash. All right, then in what rate is it decreasing in 20 days? Well, there's not much difference there. We're just simply evaluating the derivative after 20 days. So negative 0.016 times 20 squared plus 0.02 times 20. And let's see what we get now. So negative 0.016 times 20 squared plus 0.02 times 20. So after 20 days, it's decreasing by 6 grams per day. So that would be negative 6 grams per day. Next, the question says, rounded to the nearest tenth, what will the mass of the tumor be in 5 days? So the mass of the tumor. The mass of the tumor is measured by the function m of t. So m of t is going to be the mass of the tumor in grams. And the reason I know that is because the derivative of that would be m prime of t, which would be the mass of the tumor, how it's changing per day. So grams per day. So anytime you have a per day, that's telling you you're dealing with a derivative. If you just have a grams or a meter, that's just a measurement. So that's the original function. So we need to find this original function. So the mass of the tumor after 5 days. Well, first off, we need to get that function. So m of t is going to be the antiderivative of the derivative of m of t. So that means I need to find the derivative of negative 0.016 t squared plus 0.02 t dt. So using the power rule, this would be negative 0.016 times t cubed over 3 plus 0.02 times t squared over 2. Oh, I don't need the integration symbol any longer, and we've got the plus c here. Now, 0.016 divided by 3, that doesn't divide evenly. I think I'll just leave it as such. So we'll just leave this negative 0.016 divided by 3 t cubed. This would just be 0.01 t squared plus c. Now, at this point, students usually have kind of quit writing in plus c's, but they're extremely important. Mathematicians don't put stuff in that's not extremely important. The dx's look repetitive. They're important. You have to have them. The c's, they look repetitive, but they're very important. You have to have them. Because here's the thing. Most students at this point would now just disregard the plus c, just throw that out, and then start plugging in 5 into this function and getting the wrong answer. So, how do you get the correct answer? Well, this isn't the function. This represents a family of functions, and you have to figure out which one passes through a specific data value that's given to you initially. So, for instance, if a tumor of this particular type has a mass of 150 grams just prior to the start of radiation treatment, that's an initial value. So what that's saying is when we start radiation treatment, so at t equals 0 in terms of radiation treatment, the mass is 150 grams. Now, don't fall into the next trap, which is to just change c to 150. It might work out that way. Sometimes it does. Sometimes it doesn't. Just solve. It's not a big deal. So we're saying the mass at time 0, which would be negative 0.016 divided by 3 times 0 cubed plus 0.01 times 0 squared plus c. That mass at that time 0 is 150. Now in this case, it is going to work out very simply because this right here multiplies to 0, that multiplies to 0, we're left with the initial value c is just 150. So we now have the mass of the tumor at any time t is going to be negative 0.016 over 3 times t cubed plus 0.01 t squared plus 150. That's what we're going to use in order to solve the last two remaining parts of the problem. So, I'm running out of space here. I will come up here and do that. So for part C, we want to know what the mass of the tumor actually is after 5 days. So not how it's changing, but what it actually is. So the mass of the tumor after 5 days would be, in this case, negative 0.016 over 3 times 5 cubed plus 0.01 times 5 squared plus 150. So after this number of days, 5 days, the mass of the tumor is still 149.6 grams. Now, if we hadn't done the plus 150, look what we would have gotten. So let's do this. So second entry, and I'll just delete the plus 150. Negative 0.4. Does it make any sense at all to say that the current mass is negative 0.4 grams? It should throw up a red flag there. mass can't be negative. The rate of change of mass can be negative because it's decreasing in size, but the mass itself can't be. So you have to have that initial value of 150. All right, and then part D is similar, but we're just simply evaluating it at 20, I believe. Yep. So I'll take my function here, and it's negative 0.016 divided by 3 times 20 cubed plus 0.01 times 20 squared plus 150. And as long as I've typed that in properly, then here is our mass. So 111.3 grams.